All right, day two is more of like a parsing thing. It's not too bad, but I think an object-oriented solution is kind of a nice way to go around it. So this is how I went and handled the question. So when you read through the question, you basically end up seeing that you have some kind of inputs like this. And for each game, you'll have, first of all, you have a bag with only red, blue, or green marbles. Each semicolon separates each different reveal. And then in each reveal, they're basically showing you some marbles. Part one, they want you to basically see how many of these games are possible given that you only have 12 red, 13 green, and 14 blue. And so, for example, one is possible because you never have more than these numbers in a reveal. But for example, game three would not be possible. And if we look why, here, there's 20 red. So all right, nice little intuitive way of coding this is, first of all, I want to make something object-oriented because then I can kind of write all these functions for it. And so what I'm going to do is I'm going to first create a class called class cube set. And so this will represent like here, it's going to represent one set of like this, or it could represent like these cubes. And so if I go ahead, I'm going to do our constructor. And I'm going to take in a red, green, and blue. And I'll just define all of those. All right, so now that we have these, what I'm going to do is, if I look at the question, so first of all, we need a way to parse all of this information out. And so I'm going to create a little method here, like a helper. So given a reveal, because the way they call it in the code is they'll basically reveal different sets like this. So given some string like this, I want to extract this into a cube set. So what I'm going to first do is I'm going to split these up. So for token in reveal.split, and I'm going to split this on a comma. And so what I'm doing here is when I have a reveal, something like 3 red, 5 green, 4 blue, this will split this up and we end up here. Let me just do this so I'm not getting this error. We'll end up with something like this. And these will all be strings. So now from this, I need to parse out this information. So first things is, if you notice, when I split on just this comma, it's actually going to add a little leading space to stuff like this. And that's not something I necessarily want. So we'll have to account for that. But what I can do is, just because I've done this before, makes it a little bit nicer. We're going to have something like colors, and we're going to have red, green, and blue. And then now we'll also have a list for values. And this will be something that's just 0. And this is basically the same as saying 0 3 times. So now what we can do is for index and color in enumerate colors. So what this is going to do is it's going to be I is equal to 0 for red, 1 for green, and 2 for blue. Then from this, we can go ahead and say if color, so for example, for the first one, it's if red is in my token. So if red is in this string here, or in this string here, or in this string here, then I want to go ahead and I want to add to that value. So the 0th index is going to be the red value, 1, green, so forth. So we'll do value at I for the index plus equals, just in case we for some reason had an input where it's like 3 blue, 4 blue. Doesn't hurt us to add this. So then we'll do value at I is going to be equal to, and I need a way to parse this out, and I also need to handle potentially having this space here. So I'm going to do token dot strip. So dot strip will get rid of all of the extra white space, so it gets rid of this. So we'll have something like that instead. And then from this strip, we're going to go ahead and I'm going to split it again on a space like this. And then finally, with the first value, I'm just going to turn all of this into an int. And I'm realizing now it actually might just be easier and more readable if I do something like this, and I believe this should work. So let me explain what this is doing. When I have a token like this, where I have a leading space, 5 space green, like this, And I can actually just show this right here. So if I have some string that's going to be like I'll put a couple spaces, 5, couple more spaces, green. And like, we'll have something like this. So some real weird input. If I print out s, we see this. If I do s.strip, and I give it no arguments. Oh, sorry, not strip, sorry. s.split. Oops. Notice how it gets rid of all this white space, and it gives me a list of each of the elements like this. So when I do split like this, and when I get 0, I'm getting just the first thing. If you notice in the input, if this is our reveal, if I split it on the comma, we're only going to get something where it's a number and then the name of the color. So now, here, if I just turn this into an int, so if I do s.split 0, and I make it an int, oops, then I just get the number. And so that's what we're doing here, and we're adding this to the value. And so now, after all of this runs, we're basically going through each token, so each one of these things, and then we're adding these into, we're going through each color for each token and adding that to our value list. Finally, we're going to return a new cube set, and it's going to take in, so we could do, oh, sorry, this should be a values. Here we would have values at 0, values at 1, values at 2. But a nice little thing we could do, just to make our code a little bit more Pythonic, is we can do something called splat, or unpacking. Basically what this is doing is taking some iterable and just spreading it out the exact same we did here. And so now, just to test this, let's go ahead and, and one little quality of life thing we can do is we can add a string, and I'll show why in a second. So if we go ahead and, skipping ahead a little bit, so the thing that they want you to do for part 1 is they want to see how many of these can fit with 12 red cubes, 13 green, and 14 blue. So we're going to go ahead and make that as one of our things. So we'll do total is equal to cube set. And if I do 12 red, 13 green, 14 blue, I print out total. Look at what we get. Oh, sorry. Here. See how we're getting this? This is because we're trying to print out an object. And Python doesn't know what we want this to output as. So we can override its string function. And this is what gets called when it tries to turn this into a string, because internally, print is going to basically call something like this. So when we overwrite this, what we can do is we can return some different string we want to print. So if I just return a smiley face, it'll always print a smiley face, but that doesn't help us. So instead, I'm going to just return a tuple of self.r, self.g, self.b. But the problem is this is a tuple, not a string. So I'm going to turn all of this into a string. And notice how I have an extra pair of parentheses, because otherwise it would treat all of these as separate arguments. So now we can see we print out our new little custom object pretty like this. All right, so now we have this total, and let's go ahead and test this parse function. So if I parse, and we'll pass in a string of like 3 blue, 4 red, 15 green, we can see 4 red, 15 green, 3 blue, because it's RGB, and that's perfect. So now what we want to do is, if we look at the question, we're given these games, and looking at the input, it looks like all of these line up with whatever the line is. So as long as we just one index when we iterate through it, we should be fine. So I had to cut the video here because I just recorded for like an extra like 5-10 minutes, and I realized I never changed the scene back from this one. So this is going to be the second time around. But so now we have our games, and we can see that each line represents the name of the game itself. So we don't need to worry about actually parsing this part out. So what we're going to do is for line in input.split lines. And if I print out my line, we can see that we get something like this. And since we want to get this number, we can use enumerate. So we'll do line, we'll do game num is equal to this, and we'll toss in an enumerate. And then now, game num, we can see that we get this, except it's 0 indexed. So just to kind of make our lives a little bit easier, we're going to just add 1 to this variable at the start of each loop. And then now you can see we're printing out this, and we're getting just the game number without having to parse it. So now to actually parse out each of the individual reveals, what we can do is this. First, we're going to do our left hand, or we're basically going to split this on this little colon here because there's only one in each line. And since for each line we know there's always going to be one and there's two things on the left, one on the right, we can just do something like this. And so what this is doing is it's splitting this up. And since we always know from our code, this will always give us two objects, like a list with two things, we can just directly unpack it into two variables like this. And since this is not being used, good Python practice is to leave it as an underscore, just so we don't really touch it. So now if I go ahead and print out this right-hand side, we can see we're just getting these individual reveals. And then for each of these, if I split this again on a semicolon, you can see that we're getting each individual reveal instead of all of them together. So now we want to parse through all of these. If you look at the question, it's telling us that we want to basically check if this is less than whatever our total cubes are. So 12, 13, 14. So here, this would be 4 red is less than 12, 3 blue is less than 14 blue. And so first, let's just parse all these out. So let's do, for each line, we're going to have sets of cubes for reveal in right-hand side dot split, like we had earlier. Then we can do sets dot append reveal or parse reveal. And now if I go ahead and try to print out my sets for each line, we end up getting our old weird little representation of our object again. And the reason why is when we print out a list, it doesn't actually try to call set on everything inside of it. So instead it's calling the representation function. And that's defined as, this repo. So if we overwrite this also, now we get our pretty little printing like this. So you can see for our first line here, we get 3 blue, 4 red. So 4 red, 0 green, 3 blue. And we get 3 different reveals, which is exactly what we want. And so now we just need to make sure that all of these is a subset of whatever our total cube set is. And so let's go ahead and define a subset function. So def is subset. And this will take in another cube set object. And so inside of this, what we can do is return self.r, and this needs to be less than or equal to other.r. And self.g has to be less than or equal to other.g. And we'll finally do this for blue. And we'll wrap all of these in parentheses so that it doesn't try to complain like it did on day one. And then now we have a subset function. So finally, let's go ahead and also create our part1 variable because it looks like we're, here, let me show this. We are adding up all of the game numbers that are possible. So if I return this, right now we should get 0 and no errors. So now let's go ahead and do this. If we want to see if all of the individual sets are subsets of the total, then in that case, we should add the game number to our P1. We'll do if all of S, so S is less than, bear with me, S is less than, or sorry, is subset. So if individual sets are a subset of total for S in sets. So, and let me just make this clear so the syntax is defining. What this is doing is it's basically like a little mini list comprehension where for each individual set in sets, we're checking if this is a subset of the total. And then all will only return true if all of these parameters are true. So now if that's the case, we'll do part1 plus equals game num. So let's go ahead and test it on just the test case. You can see we get 8. If I test on my input, I get 279 point, having a stroke, 2,795. If I look at my advent of code, that was my right answer. So now let's look at part 2. Here, what they're telling us to do is they want us to make sure, or they want us to see for each game, what is the least amount of cubes we need so that the game would be valid. And so essentially we're taking the max of each of these things. So for example, in game 1 here, we could have done this with only 4 red 2 green, and 6 blue. And the 4 red comes from here. This 4 red, this is the max one. The most green we ever need is 2, same here. And then we have 6 blue needed here. And so let's go ahead and enter code. Let's just create a max function. So we'll do something where we basically increment whatever our current one is by whatever the other one gives us. So we'll do self.r is equal to max of self.r other.r. And we'll do this 3 times. So I'll change this to green. And then change this to blue. All right, so what this is doing is basically, if I take CubeSet and I call dot max and I give it another CubeSet, it'll update all of its values to whatever the maximum is between either of them. And the whole reason why I'm doing this is because this is all I need for this question. I don't need to really worry about modifying the cubes, because when I actually go to approach it, I'll just do max cubes is equal to a new cube set, which is zeros. Now, for each set in sets, max cubes dot max s, and then if I print out this, what this is doing is it goes through every single set in my sets, and it is updating max cubes to contain the maximum between whatever it has and the new object. So if I print this out, oh, this is one of my things. Let me print this on the test. We can see here we get 426. And if I look at admin code, 426. Second one gives me 134, 134. So I'm already convinced at this point. So let's see what else we need to do for it. It's saying it wants a power, and power is just multiplying all of these together. And then we add this up for every single game. So we'll go ahead and create a new variable for part 2. And by doing this, it's basically assigning these, or 0 to all of these. And then now, here, I'll go ahead and do part 2 plus equals max cubes, but I need a way to get its power. So I'm just going to create a new function, just make it pretty, def power, and we just return self.r times self.g times self.b. And let me get rid of this print. And we need to finally return it. If I print this out on the test, we can see we get 2286. And if I look here, 2286. So let me go ahead and run it on my input. We get 75561. And I already submitted it, 75561. And so that's our answer. So in kind of just overall review, the way that we did this question is we created a CubeSet object. We go ahead and parse each of the individual lines so that we can extract the relevant information. And then for part 1, we get all of those individual sets, and then we check if all of them are subsets of this total set that we hardcode in. If it is, then we add the game number to our part 1 score. For part 2, we create a CubeSet with all 0 values, and then we go through each set and we basically make it so it's the maximum between both of those. And then finally, we just add the power to part 2. All right. If you have any questions, feel free to leave a comment or just let me know, and I'll try to get around to it. Good luck.